Hi, and welcome back to Chapter 5. This is going to be the test review. It's going to be a brief test review covering textbook pages 345 through 411. You want to have your notebook paper out because you're going to be writing everything that I write. You also want to have your pencil and possibly your headphones. This chapter is going to be on integers and the coordinate plane. The majority of this chapter was super easy. All we really need to focus on is the hard stuff, which was ordering and comparing the numbers that you're going to be converting from fraction to decimal and decimal to fraction. So let's get started. All right, so the first thing that we're going to tackle is what is the opposite of? So some of the questions may ask you what the opposite of, for instance, 16 is. So you would need to, on the space provided, we'll make a little space there, you would need to write the opposite of 16. So the opposite of 16 would be negative 16. And just to prove that point, you would have 0 here, 16 here, and negative 16 here. So that's how you know that that is the opposite. The opposite of negative 12 would then be 12, or positive 12. So you guessed it. The opposite of 5 would be negative 5. So you would want to make sure that you know that concept. The next set of problems that you're going to want to make sure that you know how to do is evaluate each expression. So the directions will say evaluate each expression, and I have a little note here that we're really talking about absolute value because that's what we were working with. Just a quick reminder too that absolute value does not mean opposite. So I want to make sure that that is in your brain. What absolute value does mean is the whatever the term is, the distance from 0. So those bars for absolute value don't mean find the opposite. It means what's the absolute value of, negative 23? Well, it's 23 spaces from 0. So as you can see, I've written 3 sort of problems here for number 2, and I'm asking you in here for the absolute value of negative 14. So the absolute value of negative 14 is just going to be 14, because if you place that on a number line, it would be 14 spaces from the 0. The absolute value of 22 would still just be 22, because even though it's on the positive side of the number line, it's still only 22 spaces. Now when you have 12 plus 15, you end up with 27, and the absolute value of 27, again, is still just 27. Here you have the absolute value of 12 minus the absolute value of 8. So just below the absolute value of 12, I'm going to write 12, because that's what the absolute value is, minus the absolute value of negative 8 is going to be 8, and then my final answer is going to be 4, right here. So you want to make sure that you know how to do those multi-step problems. I'm going to just draw a little squiggly here. Also, you could do a problem like the one shown here, the absolute value of negative 2 plus the absolute value of negative 6. So just below that, I'm going to write a regular 2 because the absolute value of negative 2 is 2. And then the absolute value of negative 6 is 6. And now 2 plus 6 is going to give you 8. You can label these problems number 3 and the one down here number 4. For this next problem, you need to be able to convert between fraction and decimal, and then you also need to be able to show me if it's a terminating or repeating decimal. So for this problem, it says to write negative 3/5 as a decimal. So the very first thing I'm going to do is bring down that negative, and then the next thing I'm going to do is off to the side, I'm going to take 3 and divide it by 5. Immediately I know I have to do a 0 decimal decimal 0 because it's going to be a fraction, so it's definitely a number less than 1. And then 5 goes into 36 times, and that's nice and even because 30 minus 30 is 0. So converting it here to a decimal, we get negative 0.6. So that's what you would write on your answer line, negative 0.6. All right, problem number 6 here says to write negative 2/3 as a decimal, use bar notation if needed. So the first thing I'm going to do is bring down that negative, just like I tell you all the time to do. And then off to the side, I'm going to do 2 divided by 3. So now immediately we're going to do our 0 decimal decimal 0. And then we know it's going to go in 6. 6 times 3 is 18. We have 2 left over. We can add another 0. And we're in the same spot with that 20 again. So as we can see, we're the 0.6666, it's going to go on forever and ever. So this is where we're going to need that bar notation. So your answer should be 0.6 with one line over the 6. Now remember, when you're using bar notation, whatever the bar goes over is going to be the one that repeats. So if it was, I'm going to go to the bottom here because this has nothing to do with this one. So if your answer was 0.8383, blah, 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 that would actually look like 0.83 and the bar would have to be over the 8.3. You wouldn't want to do, if it was the same problem, you would not want to do 0.83 with just that, because that is actually saying 0.83333, so, and so on, you know. So you don't want to do it that way. You want to make sure that you know exactly where that bar goes. So now you have the problem for number 7, compare 1 2/3 to 1 3/5. So you would need to convert both of these to a decimal. Because of the previous problem, you know that this should be 1.6 with a line over it. And because of a previous problem, I believe it's the problem that we started with. Hold on. 3/5, where's the, okay, so 3/5 was 0.6. So now we can come back and we know that that's going to be 1.6. Now the difference though is that this is 1.6666 and this is just 1.6, and everything after it would technically be a 0. So your answer for this problem has to be that 1 2/3 is greater than 1 3/5. Number 8 says, Jenny got 5 out of 9 questions correct on her quiz. What is her average expressed as a decimal? So the first thing you want to do is view this question as a 5 out of 9, so a fraction. From here, you're going to need to set this up as a regular division problem. So you'll use 5 divided by 9. And of course, you're going to add 0, decimal, decimal, 0. And then 9 goes into 50 5 times. And you get 45. When you subtract that, you're going to have 5 left over, and then the cycle continues. You're back to 50 again. So your answer expressed as a decimal should be 0.5 with a line over it. If you don't have the line over it for the bar notation, it will be marked incorrect. All right, for the next problem, it's going to say which set of rational numbers is ordered from least to greatest. So for these problems, you'll be given 4 sets of numbers, and you'll have to order them all from least to greatest and see which one is in the correct order. So I'm just going to show you here how to order 1 set of numbers from least to greatest, but you will be given 4. So the numbers you're given here are negative 4.3 with a bar over it, 4.06, 4 1/4, and negative 4 1/5. So to be able to compare these, you need to first get them all into decimal format and then look at the negative integers. So the first one, negative 4.3, is already done for you. So you're just going to leave that as it is. And actually, the second one is also done for you. So that's 4.06. So now we need to address the last two. 4 1/4 is something that you should already know. 4 point, because you've got that whole number there, and 1/4 needs to be something that you've memorized as 0.25. So that's like a quarter of a dollar. Then the last one is negative 4 1/5. So we're going to start by writing negative 4 point, and then we need to change 1/5 into a decimal. So as you can see, I've set it up as 1 divided by 5. Then we've added the 0, decimal, decimal, 0. 5 times 2 is 10, and we get 0. So now we know that that number here is going to be negative 4.2. So now that you have all of the numbers, you have to order them. So the first thing that you're going to look at is the negative numbers. And you need to remember that the greater the negative number, the less it really is. So negative 4.33333 is actually going to be your least number because it's farthest away from the 0. Next, you will have the negative 4 1/5. You want to note that I wrote negative 4 1/5 and not negative 4.2 because you have to use the original format. You're not going to use the format that you used to convert it to. Then you're going to deal with your positive integers, so you have 4.06 and 4.25. Since you have positive integers, they're actually just like you would think. So 4.06, if you think of those in terms of money, 4.06 is like $4.06. So 4.06 would be next, and then the last one would be 4 1/4. Again, please note that you're going to use the mixed number, which was given to you originally right here, as opposed to the decimal format that you used to actually put it in order. All right, so for number 10, you're going to see a number line, and there will be 3 dots plotted. And the question will say, which set of integers is graphed on the number line? You'll be given a choice between 4 different sets of integers. But basically, you just need to make sure that you know how to identify the integers that are graphed. So for this particular set of integers, you're going to be looking at negative 4, negative 2, and 1. Now you want to keep in mind that this may not be the order that they're displayed in. They may be displayed in different orders, but that these are the points that are graphed on the line. For number 11, you're going to see a coordinate plane that looks something like this, and you will see this rectangle drawn on the coordinate plane with points A, B, C, and D labeled. So the next set of questions, you're going to have to listen closely because I'm going to write them on the next screen, and then we're going to flip back to this screen to do the work. So for this set of questions, it's going to give you a story about a library or a post office or something along those lines. But the bottom line is you need to be able to find a reflection of point A across the x-axis. So now that we know we're going to have to find a reflection of point A across the x-axis, we're going to go ahead and go back. We're going to look for our point A. So you can see that it's right there where it's labeled as A. Then we need to find the x-axis. Notice I've circled it here in green. So the reflection across the x-axis, remember, means that first you would want to have point A listed. So A is at 1, -2. That's our point. Then remember you want to go X and Y. And remember, if you're going to do a reflection, you're going to have that little sort of apostrophe looking sign. And since you're going to be reflecting across the x-axis, remember whatever axis you're reflecting across is the one that stays the same. So you're going to keep the 1, and then you're going to use the opposite of -2, which is actually 2. So now you're going to plot the A on the coordinate plane. So now we're going to go over 1 and up 2, and we're going to plot that point right there, and we're going to label it with A and that little apostrophe to show that that is our reflection. And on the test itself, it's going to ask you to identify the ordered pair. So this is what you would write on the answer line. Then for the same problem, it's going to ask you to reflect point D across the x-axis. So let's do that. The first thing we need to do is write the ordered pair for point D, which is going to be 1, -4. Don't forget to mark them with X and Y. And then the reflection of point D across the x-axis means that the 1 stays the same because that's our X value. Then we take the opposite of -4, which is 4. So now we're going to plot that point, but remember this is the number, or the ordered pair rather, that you would write on the line for your answer. So as you can see, I went ahead and plotted point D, and my answer that I would put on the line would be 1, 4. And you need to make sure that you have the parentheses and the comma so that it looks like an ordered pair. And then the last question is going to ask you to reflect a point across the y-axis. So this one asks you to reflect point B across the y-axis. So the first thing we're going to do is write the ordered pair for B. So the ordered pair for B is going to be 4 rather. 4 and then -2. So 4, -2. Remember, we're going to label those with X and Y. And now remember, they want you to reflect it this time across the y-axis. So that means the y value, that -2, will stay the same, and it's actually the x value that will be the opposite now, which will now be -4. So this would be the answer that you would put on your answer line, and then to be able to plot that point, you would plot -4, -2, which would be right here, and you would label that with the reflection of point B. That's how you label the reflection. And the last pieces of the test are pretty simple from here. So let's go ahead and skip that page. For these portions, you're just going to be replacing with a greater than, less than, or equal to sign that makes it true. So when you're talking about integers, you are going to be comparing them with those signs. So the following example problems are listed here. So if you have -2 and -7, you have to mark which one is greater than, less than, or equal to. So -2 is actually going to be greater than -7. And you need to think of it like this. This is 0, this is -2, and this is -7. So -7 is farthest away from 0. That's how we know that it's less than. So now for 5 and -1, anytime you have a positive integer, no matter what number that is, it's always going to be greater than. -7 and 11, obviously number 11 would be greater because it's positive and the other one is negative. And the absolute value of -6 and 6 is actually going to be equal because the absolute value of -6 gives you 6. So now you're comparing the two and they're the same. Okay, so now you're going to also be given a list of numbers to order from least to greatest. So the first thing you want to do is make sure that you underline or pay close attention to it's asking for least to greatest. It will not always, so you want to make sure that you do that. And then you want to think about where these numbers would fall on the number line. If it helps you to draw a number line, then definitely do that. So the greater the negative, the less that the number actually is. So -6 is going to be my least value, then -4, then -1, then 0, and then our only positive integer, which is 3, because remember 0 is neither positive nor negative. This next question you'll be asked, you will not have a coordinate plane to look at. You can draw one if you would like. You can think of what one would look like in your head. But for this problem, it says, in what quadrant would you find -2, +3? So for me, if I were you, it would just be easier for me to draw a little makeshift quadrant and go, okay, -2 would be back 2 and then up 3, so that would be about here. And then you need to make sure that you know which quadrant that is. So starting from the top right, that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So obviously, as you can see, the answer for this one would be quadrant 2. So again, if it's easiest for you, you can just make a little ordered pair, or I'm sorry, coordinate plane like this. So the next question that I have here, number 15, will cover probably 2, maybe 3 questions that are going to be on the test. And it says to write an integer to describe each situation. So for instance, Matt found a $5 bill. So for Matt finding a $5 bill, that's going to be a positive integer, so it'll be +5. The next one says the tub drains 4 inches per minute. So because it's losing water, draining means, losing water, so it's going to be a -4. So you just need to know how to assign an integer to a situation like I've done here. And now you see my cute little meme at the end. It says the human brain is awesome. It functions 24 hours a day from the day we're born and only stops when we're taking an exam or fall in love. So don't let that be you. Make sure that your brain does not stop while you're taking the exam, and good luck.